Math 2414, sequences, video 11, factorials. Some of you may already know what a factorial is, but some of you may not. So let's start with the definition. If n is a positive integer, then n factorial equals n times n minus 1 times n minus 2 all the way down to 3 times 2 times 1. And by definition, 0 factorial is equal to 1, sort of. The actual definition of a factorial in a larger context, using something called a gamma function, you can actually prove that 0 factorial is 1. For our purposes, we'll assume that 0 factorial by definition is equal to 1. Real quick example, let's say you wanted to know what 5 factorial equals, 5 with the exclamation mark. That simply means to start with 5 and multiply all the way down to 1. So you can see why it's only defined for integers. And then that would equal 120. But how does this play out in sequences? Well, let's take a look at a couple of examples. For example, let's consider the sequence an equals n factorial over n plus 3 factorial. At first glance, something like this can seem intimidating, but we're going to run across factorials quite a bit towards the end of this chapter, so it's important to get comfortable with them now and what they mean. Here, so I quit looking to the side. All right, so if we're going to take a limit, we need to try to simplify this fraction. And to simplify it, we need to write what it actually means. For example, the numerator means n times n minus 1 times n minus 2, all the way down to 3, 2, and 1. In essence, when you evaluate a factorial, you start with the first number and then multiply by every number lower than that until you get to 1. So how would n plus 3 factorial look? Well, we would start with n plus 3, and then we would multiply by the number 1 less than that. Well, what is 1 less than n plus 3? The answer would be n plus 3 minus 1. But when you combine the plus 3 and minus 1, you get n plus. Again, all I did is subtract to get from here to here. Subtract 1. That's what the definition says. You subtract 1 to get from one factor to the next. So n plus 3 minus 1 is n plus 2. What's n plus 2? Minus 1. 1. Keep going. What's n plus 1? Minus 1. N. What's n minus 1? 1. And this will continue until we get all the way down to 3, 2, and 1. Now, why did I take it all the way down to n and not stop with back to 3 factors like I did in the numerator? Because here's a little nice something about factorials in general. When you have one on top of another, there is going to be some massive cancellation. You just got to figure out where it begins. So I broke the bottom factorial down until I got to the beginning of the one that was on the top. Because once I reach the beginning of the other factorial, because these are all factors, and that's what you can cancel in a multiplication problem, you're gone, you're gone. In fact, everything's gone after the end. So what does that leave? The bottom, it leaves n plus 3, plus 2, and n plus 1. And then on the top, since I canceled all the factors, it leaves a 1. And now we can look at the limit as n approaches infinity. We'll put a therefore here because this is going to end real quick. Well, what's this limit? Well, the numerator is static, it's 1, and the denominator is growing really fast because it's a cubic polynomial. If you multiply it out, let's start with it in cubic. So however you look at it, this limit is equal to 0. Sequence converges to 0. Because the fraction reduces from a ratio of factorials to 1 over n plus 3 times n plus 2 times n plus 1. So when the n gets larger, the fraction collapses to 0. Wish I could say that they were all this straightforward. Not always the case. Let's consider this one, where we have an equals n factorial over n to the nth power. Now this one's a little trickier to decipher, even if you write out what it means. For example, n factorial, we know what that means. It's n times n minus 1 times n minus 2, all the way down to 3, 2, and 1. And n to the nth power means n times. Now the numerator has n factors, and so we can match up the factors in the denominator with the factors in the numerator. Now let's split it up until we get a bunch of individual fractions. Since everybody has their own denominator. Everybody has a denominator of n. And we have n minus 1, 2, all the way down to 3, 2, and 1. All right, so let's think about this for a second, because I'm going to show you a trick that I've actually shown you before. We're going to squeeze our terms. So what can we squeeze them between? Well, here's another trick. When you are trying to find something greater than an expression or less than an expression, you can look at individual factors and see if they have bounds. For example, that's equal to 1, but isn't this less than 1? And isn't this less than 1? In fact, all of these are less than 1, no matter what the n is, because the numerator and denominator start out equal at the beginning, then the denominator stays the same while the numerator gets smaller. So all of these are less than 1. And even the last one is less than 1, but I'm going to leave it there for a second. Because all of these factors are less than 1, we know that this product is going to be less than 1 times 1 times 1 times 1 times 1 times 1 over n. Well, 1 times 1 times 1 times 1 over n is just 1 over n. And so what we've just done is we've shown that the nth term is less than 1 over n. But at the same time, it's also greater than 0, because both n factorial and n to the n will be positive for any positive integer n. So we just squeezed this guy between 0 and 1 over n by analyzing individual multipliers and recognizing that all of them are less than 1. And so when we replace those with 1, we get a larger value, 1 over n basically. Since 1 over n approaches 0, then a to the n approaches 0 by the squeeze theorem. I'll admit that was a little sneaky and a little unprecedented in this class, but I just want to show you that when you reach a certain level of math, and we're there, have to have some tricks in your arsenal, and this was one of the tricks. Bounding the expression above by 1 over n by bounding individual factors above by 1. Okay, so that's the end of that video, and the end of the video for these series. End of the videos for this series.